we are going to study chemistry subject, and this is session number 8 belonging to the same chapter whose name is Aliphatic hydrocarbon. Now in this session number 8 we are going to emphasize upon the topic so called as hydration. Now, what do you understand by the word hydration? Hydration means addition of water. Hydration means what? It is basically addition of water. Now if water has to be added, it has to be added to certain important component. Addition of water. Okay, so if water needed to be added, it is needed to be added to alkene, basically for the olefin. Okay, now when alkene is treated with water, it basically is the alcohol. Okay, and this reaction take place in acid catalyst. Okay, so here we'll write down certain statement. When alkene is treated with water in presence of acid catalyst, it yield alcohol. It yield alcohol, right? So the main important product which is going to get formed over here is alcohol, right? So this hydration process is broadly classified into two categories, right? Now this addition of alcohol towards the alkene is taking place in the two ways. Now the first way is the direct way. First way is a direct addition, and the second way, direct way, okay, and the second way is indirect way. Indirect way, okay. So these are the two ways wherein the water get attacked towards the alkene to form an alcohol, right? So first let's emphasize upon the direct way. So these are the two ways for the addition of water towards the alkene. Now let's emphasize in direct method how the addition of water will take place, and indirect method how the addition of water will be going to take place towards the olefin. Okay, now here in direct method what will happen is that it will acquire the process in two ways, right? So that is for symmetrical alkene the different process, and for unsymmetrical alkene the different process. Okay, so this is just the classification wherein I am just explaining, but each one we are going to delve in more detail. Okay, so in direct methodology the two criteria are for symmetrical alkene the different way method, and for unsymmetrical alkene the process of formation of alcohol will be different. Okay, now whereas in indirect method here the addition of water will be going to take place towards the olefin, but it is totally indirect way, right? So here it acquires two important methodology, which is first one is HBO. HBO stand for hydroboration, oxidation. Okay, so this is a full form for HBO. This is first one, and second one is OMDO. So this is oxymercuration, and this is demercuration. Actually, demercuration. These are the names of method. You don't have to get confused over here. This I am going to deal in more detail. Okay, but you just have to understand that hydration means addition of water towards the olefin take place in two ways. First one is direct method. in direct method, what will happen? The addition of water will take place in two ways. That is, for symmetrical alkene the process will be different, for unsymmetrical alkene the process will be different. Whereas indirect method of addition of water involves two methodology over there. First one is HBO, hydroboration of oxidation, and second one is oxymercuration and demercuration. Within that only oxymercuration is taking and demercuration is also taking. So these are the methodologies we need to understand here. But one more thing which I would like to emphasize over here is in direct way. In this direct way, acid catalyst type of reaction take place. Acid catalyst type of reaction will take place in direct way. Okay, so this is how the reaction basically take place, that is addition of water towards the olefin. Okay, now let's emphasize upon the first type of hydration, which is the direct way. Okay, now for direct way of addition of water is acid catalyzed reaction. Acid catalyzed reaction. Okay, so here what happens is that acid plays an important role over there, right? So here in this case, first it has been divided into symmetrical alkene, and then second one is unsymmetrical alkene. Okay, now for symmetrical alkene, for this symmetrical alkene, here the basic example we'll take, then you'll understand more precisely over here. You guys will understand more precise. Now this is symmetrical alkene. Why we say this as a symmetrical alkene? Because across the doubly bonded carbon atom, same number of hydrogen is there and same number of carbon atoms are there. Thereby it is considered to be the symmetrical alkene. Okay, so here what happens, children, is that when the addition of water will take place, here the hydrogen atom will go and get attached to any of the carbon atom over here. Now this is suppose carbon number 1 and this is carbon number 2. This hydrogen atom will go and get attached to the carbon number 2, and this hydroxyl ion will go and get attached to carbon number 1. Anyway round, because here the unsymmetrical thing is not there. Unsymmetry means what? The number of carbon atom and number of hydrogen atom which are present across the doubly bonded carbon atom, there it is same. So anyway round, hydrogen will go and get attached to whichever carbon atom and hydroxyl will go and get attached to whichever carbon atom. The most important thing is that when hydrogen and hydroxyl is going and getting attached to the respective carbon atom, that time this pi bond will be going to get breakdown, right? One bond basically will be going to get breakdown, cleave over there, then and there itself the hydrogen and the hydroxyl will go and get attached to it. Okay, and yes, here we wrote acid catalyst. This reaction basically take place in presence of H plus ion, right? Means H plus ions you are going to get from certain diluted sulfuric acid. Okay, so once it is getting attached to the carbon number 1 and carbon number 2, both the groups, the reaction will be going to get formed, the product will be going to get formed in such a way that if hydrogen is going and getting attached to carbon number 2, it will form CH3, correct? And then the bond will be going to get break. For this CH2, OH is going and getting attached, OH, right? So what is this? The main important product wherein it has been formed over there is alcohol, because alcohol is having a functional group so called as ROH, where R stands for alkyl group and OH is a hydroxyl, right? Alcoholic group. So this is ethyl group and this is OH. So the name for this product is ethyl alcohol or ethanol. This is the primary alcohol, 1 degree alcohol. Okay, so this is the primary alcohol. So this is a symmetrical alkene. For symmetrical alkene, the way is different. Here the hydration is taking place. The addition of water is taking place for the symmetrical alkene in a very simplified manner. But now when I consider the addition of water for unsymmetrical alkene, the way will be different. Okay, now let's understand for an unsymmetrical alkene. Okay, CH3, CH, double bond CH2. Now this is unsymmetrical alkene, correct? This is unsymmetrical alkene because across the carbon-carbon doubly bond, the number of hydrogen atom and the number of carbon atom is different. Is different over here, right? Here you can see 1 carbon and 2 hydrogen is there. This side you can see 2 carbon and 4 hydrogen is there. So number of hydrogen and carbon atom is very much different over there. The name for this alkene is propene, prop 1 in basically, prop 1 in. Okay, the name for this alkene was what? Ethene, right? 2 carbon compound, ethene. So propane, when it undergoes hydration, means addition of water, okay, in presence of acid catalyst, which is getting from dilute sulfuric acid, okay. So that time what will happen? Here what we did for symmetrical alkene, hydrogen we can add to any of the carbon atom, hydroxyl we can add to any of the carbon atom in symmetrical alkene. But this is not applicable for the unsymmetrical alkenes. For unsymmetrical alkene, there will be one rule called as Markovnikov rule, wherein we studied in session number 6, which was saying that if an unsymmetrical reagent, now this is unsymmetrical reagent, water is an unsymmetrical reagent which is consisting of hydrogen and hydroxyl, because hydrogen is carrying positive charge, hydroxyl is carrying negative charge, del positive and del negative, polar molecule, right? So if this reagent is carrying negative charge, so according to the Markovnikov rule, what it was saying, the negative terminal, the negative group of unsymmetrical reagent will go and get attached to the alkene, unsymmetrical alkene, to that particular unsaturated carbon which is having less number of hydrogen atom, right? I repeat once again, according to the Markovnikov rule, the negative group of reagent will go and get attached to that carbon atom which is having less number of hydrogen atom, and this addition will take place across double carbon-carbon double bond, right? So here if you compare between carbon number 1 and carbon number 2, carbon number 2 is having less number of hydrogen atom. So thereby this negative terminal of this water will go and get attached to the carbon number 2 and hydrogen will go and get attached to carbon number 1, correct? So thereby we will get the product in such a way that the product will be like CH3, right? CH3, the first terminal carbon will be as it is. Then across CH, the hydroxyl group is going and getting attached, hydroxyl group. So when this attachment of this OH group is taking place, the bond has to cleave, right? The pi bond has to cleave over there. So that time the bond has broken down, and then this hydrogen will go and get attached to this CH2, and thereby we are getting CH3. So what is this? This is also an alcohol, but the name of this alcohol will be different, whose name is isopropyl alcohol, or it is also called as propane 2-ol. See, 1, 2, 3. Now propane is the alkane, parent alkane, but in place of E, I am going to add ol, alkanol, no? If this is the alkane, E will be going to get replaced by OL to form alkanol. Okay, so propane, E will be going to get replaced with ol, but at second position ol is there, OH group is there, so thereby its name will be propane 2-ol, or the common name is iso. Iso means at second carbon OH group is there, isopropyl alcohol. That is the common name. Okay, so this is how for unsymmetrical alkene the Markovnikov rule is applicable. For symmetrical alkene there is no Markovnikov rule, because across the carbon-carbon doubly bonded, the number of hydrogen and number of carbon atom is similar. So anyway around the hydrogen will go and get attached to any of the carbon, and hydroxyl will go and attach to any of the carbon. Whereas in unsymmetrical alkene, the hydration will take place according to the Markovnikov rule in presence of acid catalyst, and you are going to get the second degree alcohol, that is secondary alcohol basically, which is propane 2-ol, right? So this is how the hydration process is taking place towards the alkene by direct methodology in presence of acid catalyst. Okay, now let's emphasize upon the second way, which is indirect way. So I guess you people have been understood with the direct way, it's very simple. Okay, then now let's understand for the indirect way, which is accompanying two important methodology over there. First one is HBO, second one is oxymercuration demercuration. Okay, so these are the two methodology which are coming in the indirect way of attacking water molecule towards the olefin. Okay students, now we'll talk about the second methodology of hydration process is nothing but the indirect way of attacking water towards the olefin, and in that first we'll emphasize upon the first methodology, which is hydroboration, oxidation. Hydroboration, oxidation. Okay, now this technique or this method is also applicable for preparing alcohol from the olefin. Okay, so here also the alkane is going to converted into alcohol, when it is treated with boron trihydrate or trihydrate boron, anyway round, trihydrate boron. So you are going to yield alcohol over here. So when alkene is treated with the trihydrate boron, we are going to obtain alcohol over there. Okay, so how that mechanism basically take place, and it's really very interesting. Let's understand this. So here what happens children is that the olefin, so called as alkene, so which alkene we are going to use over here is propane. Okay, prop 1N. So when this is propane, okay, so when this propane is treated with boron trihydrate, okay, so boron trihydrate, I am going to write in this manner, BH3. So this is boron trihydrate. Okay, so here the reaction will be going to take place in such a way that here the negative terminal, whatever the negative group will be going to get obtained, that negatively group atom will go and get attached to the positively group atom of the alkene. I repeat once again. Here whatever the negatively charged atom is formed over here after the polarization process, so that time that negatively charged group will go and get attached to the positive terminal of positive carbon atom of the alkene, and vice versa. Whatever the positively charged atom is formed over there, that positively charged group will go and get attached to the negatively charged group of the alkene. So let's understand how these oppositely charged groups are formed over here in both the respective reactant. Okay, now in boron trihydrate, here if you compare, these three hydrogen are similar and the boron is different. Okay, now boron is highly electropositive than that of hydrogen. Boron is electropositive and hydrogen is electronegative species. So this hydrogen being electronegative and boron being electropositive, so these two electrons which are present over here, right, in this bond, out of this two electron, one electron of boron will be going to get donated towards the hydrogen. Why? Because hydrogen is electronegative, it will try to pull the electrons from the boron towards itself. Okay, so here boron will give one electron towards the hydrogen, and thereby the hydrogen will acquire negative charge and the boron will become positively charged. This is the first thing or first step which is happening over here. The next step is also the similar one. Here what happens in the next step, the boron, again the boron will give its one electron towards the hydrogen, and the hydrogen will acquire negative charge and boron will acquire positively charge. Similarly with the third hydrogen over here, so here the boron's electron will be going to get donated towards this hydrogen, and the hydrogen will acquire negative charge and boron will acquire positively charged. Okay, so this is how the distribution of charges will be going to take place, means the separation, partial distribution of charges will be going to take place between the boron and the three hydrogen, right? Whereas now let's talk about the propane. Now in propane, how the charge distribution will be going to take place. There is one effect which is called as plus psi effect. Plus psi effect means inductive effect, positive inductive effect. Now in positive inductive effect, what is happening is that the one species will donate the electron towards the another one, right, which is there in the chain form, in the relay form. This you have been studied in your 12th standard. So the alkyl group are the electron donors over there, right? So the methyl bring an alkyl group. Here what happens is that their electron density will be going to get donated in the series wise over there, right? So that is nothing but called as a plus I effect over there. So methyl group will try to donate their electron towards this CH group, and here what will happen, if the electron density will become more and more, this bond, the doubly bonded carbon atom and saturated carbon atom is there, this bond will break and this will acquire negative charge. Now this, if methyl group is going to give the electron to the neighboring one, the neighboring one will also gain the negative charge over there, but this methyl group acquire positive charge because the electron is going to get donated towards the neighboring ones, right? So this methyl group will acquire, CH2 group is acquiring the negative charge over here. Okay, now what I said, the positive charge group of BH3 will go and get attached to the negatively charged group of the alkene, right? Whereas the negatively charged group of boron trihydride will go and get attached to the positively charged. Okay, so this will acquire positive charge. Okay, so this will acquire positively charge over here. So once the electron is going to get shifted over here, it will acquire the negative charge. So this negatively charged carbon will go and get attached to this positively charged carbon, whereas this positively charged boron will go and get attached to the CH2 group. Okay, so let's see how this attachment of this groups are going to take place. So let's write down this in this manner, then it becomes more simplified for you guys. Now, if I consider, one more thing I would like to say is, if I consider the three molecules of propane, the product will be going to get obtained in such a way that, now boron is carrying positive charge in three ways. You can see the boron is carrying positive charge in three ways. Now towards this positively charged boron, the negatively charged carbon atom of propane will go and get attached. Okay, so let's do that. CH2. Now CH2 is a negatively charged. The bond will be going to get cleave over here because the electrons is getting shifted over there, right? So this will acquire in this manner. Okay, so this is how the formation of the chain will be going to take place. Now when I talk about the another one, now I just forgot to write this hydrogen. Now this hydrogen is negatively charged, it will go and get attached to this positively charged carbon, so this will become CH2. CH2, because we need to balance out both the way. Now this boron is going and getting attached to the negatively charged carbon, and this hydrogen being negatively charged, it will go and get attached to this positively charged carbon. Here the attachment won't take place, okay. The addition will be going to take place in this two carbon-carbon doubly bonded, unsaturated atoms over there, okay. So here also the same thing will happen in this second step. Here also the same thing will happen. Here this positively charged boron will go and get attached to this negatively charged carbon atom, right. And then in a similar fashion, okay, now this CH is there, this hydrogen, negatively charged hydrogen, will go and get attached to this positively charged carbon atom, right. So this will become CH2 and this CH3, okay. Similarly the same thing will be going to get happen, because 3 molecules we are taking, 3 molecules of propane we are going to get added to this boron in this manner, okay. So similarly we are going to add for this also CH2, CH2, CH3. So this is how the molecule will be going to get formed. I am showing in the most structured form of product. Now this is not the complete reaction, this is the first step. This is the first step. Now in second step, what will happen? The oxidation process will be going to happen over here. In second step, here we are going to add 3 molecules of hydrogen peroxide. In the second step, we are going to add 3 molecules of hydrogen peroxide to this product which has been formed over there, okay, which is the intermediate one. Now this 3 molecules of hydrogen peroxide will going to take place in such a way that I'll write in this fashion: OH, OH, 1 molecule here, OH, OH, 1 molecule here, okay, the addition of 3 hydrogen peroxide, then OH, OH, okay, done. So the 3 molecules of hydrogen peroxide will going to take place in this manner. Now once we added these 3 molecules of hydrogen peroxide, the alcohol, how it will be going to get formed, let's see over here. See this OH will go and get combined with this boron. Each OH, hydroxyl group of each peroxide molecule will go and get attached with this boron, okay. So this OH, in this manner I am just taking it, right. Here what is happening? From these 3 molecules of hydrogen peroxide, each hydrogen peroxide will give out hydroxyl group to this boron, right. So you can see OH from first hydrogen peroxide, OH from the another hydrogen peroxide, and the OH group from the another hydrogen third peroxide molecule will be going to get detached, and it will be going to get combined with this boron, okay. So once it is getting combined with the boron, first we will write down the byproduct. The product will be as such: 1 boron is there and 3 OH is there, 1 boron and 3 OH. So the name for this byproduct is boric acid, okay. Now let's talk about the main product over here. Now main product will be as simple it is. This group is there, you can see CH3, CH2, CH2 will go and get attached to this OH. Similarly CH3, CH3, CH2, it will go and get attached to this OH, right, this OH. Whereas the third one, CH2, CH2, CH3, this will go and get attached to this OH, right. So I have to write 3 as a coefficient for that, because 3 molecules of the isopropyl group, propyl groups are there, not isopropyl, it is a propyl, okay. So 3 groups of propyl groups are there, so it will be CH3, CH2, CH2, and yes, alcohol, OH group, 3 OH group will going to get attached, and the name for this alcohol is propyl alcohol. Propyl alcohol, or it is also called as propanol, okay. So this is how the hydroboration oxidation process is taking place here. Hydroboration, the meaning is only saying here hydrogen and boron is there, trihydride boron, and here the oxidation process is taking place. Oxidation process of trihydride boron is taking place with the help of hydrogen peroxide. You can see over here 3 hydrogen peroxide is used to bring about the oxidation of the complex which has been formed in the intermediate, right? And it's really very simple and very interesting, but you need to understand this first step. Here the separation of charge is very important, because whatever the charge, negatively charged group has been formed in a trihydride boron will go and get attached to the positively charged carbon atom of the alkene, whereas the positively charged group of the trihydride boron will go and get attached to the negatively charged carbon atom of the alkene, okay. So this is how the reaction will be going to get proceed to form an alcohol from olefin by using trihydride boron under oxidation process by utilizing the main oxidizing agent which is called as hydrogen peroxide. Okay students, we'll study the next topic which is coming under the hydration, and the name of this topic is Oxymercuration, demercuration. Now this is the methodology which is adapted for the preparation of alcohol from the olefin, okay. So what is the name of the topic? That is Oxymercuration and demercuration. So in this technique what is happening is that the alkene, the olefin, will be treated with a certain important reactant called as mercuric acetate to form an intermediate, and the intermediate which has been formed, it will undergo further reduction in presence of alkaline medium to yield the alcohol as the product, okay. So here the most important thing is that from this topic only you can make out the oxygen will be going to get combined with the mercury, that is oxymercuration, and here in this D means removal. In second step in the reduction process, the removal of mercury will be going to take place in this process. So this is the two-step reaction to yield the alcohol over here, okay. So in first step the intermediate will be going to get formed, and in second step that intermediate will undergo further reduction in an alkaline medium to give you alcohol over there, okay. So what is happening children? Let's write down in the statement form. First point, when alkene is treated with the reactant salt so called as mercuric acetate, which has a structure like that. Acetate means CH3COO, okay. This is the acetate ion, okay. But here 2 acetate ion will be going to get involved, which is going to get combined with the mercuric. Mercuric means Hg, okay. So what is happening over here? When alkene is treated with the mercuric acetate, so this is the mercuric acetate, it will yield an intermediate, okay. Now here not only mercury, one more thing which I would like to say is that mercuric acetate, along with that the water, yes, the most important one, and water is added. Water is added, okay. So alkene is treated with the mercuric acetate and water. The process, hydration, right? And water to yield an intermediate, okay. So in second step, the intermediate which has been formed over here by the reaction of alkene with the mercuric acetate and water, that intermediate will undergo further reduction, okay. The intermediate will undergoes further reduction, will undergo reduction. In fact, I'll use a word, it will undergoes reduction in presence of alkaline medium, in presence of alkaline medium to yield what? To yield the main product, which is alcohol. To yield alcohol. Okay, so this is how oxymercuration and demercuration process will take place. Oxymercuration and demercuration process will take place in this two step. Okay, now let's understand this process or methodology by taking the reaction over here. Okay, now in first step, as it is written in the statement wise, the alkene. Let's take one alkene over here. CH3, CH2, CH double bond CH2. Okay, now this is an alkene which is called as but1-in. Okay, I'm taking but1-in. Now this but1-in has to react with what? Mercuric acetate. Has to react with mercuric acetate. Now let's draw the structure of that mercuric acetate. Now mercuric acetate, acetate ion. There are how many acetate ion? Now this is the acetate ion. There are 2 acetate ion here. Yes, you can see over here. There are 2 acetate ion. So this 2 acetate ion will be going to get combined with Hg. Hg is mercury. So this is how the structure of this mercuric acetate will be there. Okay. So but1-in will react with mercuric acetate. This is what? This is mercuric acetate. And the third reactant will be, yes, obviously water, hydration process, right? So water will be added to it, H2O, to form an intermediate, to yield an intermediate. Now how this intermediate will be going to get yielded out, let's see over here. Now here what happens over here is that this OH ion from the water will go and get combined to this carbon. This is carbon number 1, this is carbon number 2. Okay, so this OH hydroxyl group of water will go and get combined with the carbon number 2. Okay, so once it is going and getting combined with the carbon number 2, okay, then the remaining one, this group you can see over here, which I am just drawing the boundary for this group will go and get attached to this carbon number 1. Okay, so the reaction is taking place between the carbon number 1 and carbon number 2. The intermediate is formed in such a way that the OH group from the water will go and get combined to the carbon number 2, whereas the electrophile, now there is a certain mechanism for that. We will not go depth into the mechanism. So this ion which is having positively charged upon this mercury, in the mechanism, there will be certain cleavage of the bond, the resonance effect will be there, thereby it will carry certain positive charge upon it. Okay, so this particular electrophile will go and get attached to this carbon number 1, and the OH minus ion will go and get attached to this carbon number 2. Okay, so the moment both the groups are going and getting attached to this respective carbon atom, unsaturated carbon atom, the product will be the intermediate. I can say the word intermediate will be going to get formed. Let's see that how intermediate will be going to get formed. Okay, so here CH3, CH2, CH. Okay, now across this CH, who is going and getting attached? OH. Okay, OH. Done? Okay, the bond has to cleave. This double bond has to cleave over there, right? So that time the another carbon CH2, carbon number 1, across this carbon, the electrophile, this group will go and get attached to that carbon number 1. So let's add that. So what is that? Hg, HgO, CO, and then CH3, right? So this is the intermediate which is going to get formed over here. Okay, so I'll write once again here, it becomes more precise. I'll write once again here, CH3, CH2, here CH is there, to a second carbon atom, the OH will go and get attached, correct? Now the bond has to cleave over there to make the bond with the another one, CH2. Towards the first carbon atom, this group will go and get attached. Okay, so what is that? Hg, HgO, CO, then CH3. Done? Okay. Then the question should arise is that what happened to this hydrogen and this group? Acetate group. One more acetate group is there, no? What will happen to them? This hydrogen of water will go and get attached to this acetate ion, right, to form an acetic acid, which is CH3 COO, CH3 COOH, right, which is an acetate ion. So this is an intermediate which you have been formed by treating But1 with the mercuric acid and the water. Okay, so this is the formation of an intermediate, which is the first step, Now let's talk about this second step. Now in second step, what will happen, children? In the second step, the intermediate which has been formed over here, this intermediate will undergo reduction. Reduction means addition of hydrogen. So here addition of hydrogen will be going to take place in presence of an alkaline medium to yield alcohol. Okay, so whatever the process we are studying over here through hydration process, first was acid catalyst reaction, second one was HBO, which is hydroboration oxidation, and third one is Oxymercuration demercuration. So these three techniques are adapted to yield alcohol from the olefin, and these three techniques are totally different from each other over there. Okay, now this intermediate which has been formed over there, in second step what will happen? CH3, CH2, CH, I am writing down the same intermediate, CHOH, then CH2, here HgO, CO, CH3 is there. So this is an intermediate. Okay, now this intermediate will undergo reduction, means with the addition of hydrogen in presence of alkaline medium. OH minus ions will be there, alkaline medium, to yield an alcohol. Now how this alcohol will be going to get formed? Now here this Hg group has to be removed from this. This entire group need to be removed from here, then only the alcohol will be going to get formed. Okay, so how this process will take place? Let's write down over here. Okay, now this is CH3 COOH. I'll write here, so there will be space for me. Now here what will happen is that this mercury will be going to get set free, then this remaining acetate ion, the acetate ion which is there, that will go and get combined with one hydrogen, and the remaining one hydrogen will go and get combined with this CH2. Let's understand. Okay, here CH3, CH2, CHOH, this will be remaining as it is. Till here the number of carbon atom and the OH group will remain same. But after this group will be going to get vanish. This group we don't want it. Okay, so that it will be going to get vanish. Okay, then how it will be going to get vanish is that here 2 hydrogen is there, right? 2 hydrogen is there. Out of 2 hydrogen, one hydrogen will go and get combined with this group, and the remaining 1 hydrogen which is there, okay, that will go and get combined with this acetate ion CH3COOH. Okay, so this 2 hydrogen ion will be utilized in this manner. 1 hydrogen will go and get combined with this CH2 to form CH3. Right, then the another hydrogen will combine with this acetate to form acetic acid CH3COOH. Correct? And then what about the mercury? Mercury will be going to get set free, right? So the mercury will be going to get set free. Okay, so this is the second step. Okay, you can see in the second step the product which is formed is alcohol. And the name for this alcohol is, you can see 1, 2, 3, 4. 4 carbon is there, right? So the 4 carbon oriented alkane is butane. But at which carbon atom the OH will be there? We need to number from this way, because the OH group should get the lowest preference. Okay, so the name for this butane 2-ol. is alcohol which is going to get formed from the intermediate by which undergoes reduction process. Okay, so this is how the process will be going to take place. I repeat once again: oxidation, oxymercuration and demercuration is a 2-step reaction. Here what happens is that the alkene, so called as but1N, when it is treated with the mercuric acetate, so that time this group which has been rounded up with the chalk, that will go and get attached, and it is behaving as an electrophile according to the mechanism. This group will go and get attached to the carbon number 1, the bond will cleave over there, and the hydroxyl group of the water will go and get attached to the carbon number 2 of this alkene to form an intermediate, right? So this is an intermediate. Now this intermediate and the remaining one, what is remained over here? Hydrogen and this acetate, that will combine together to form a acetic acid. CH3COOH is acetic acid. Now the complex which has been formed over here, the intermediate which has been formed over there, that will undergo further reduction when it is going to get combined with the 2 hydrogen in presence of the nucleophile or in presence of the alkaline medium. So that time, out of 2 hydrogen, 1 hydrogen will go and get attached to this acetate ion to form an acetic acid. Another hydrogen atom will go and get attached to this CH2 group. You can see over there, right, to form an butane 2-ol, and the Hg will be going to get set free. So this is how the 2-step reaction will be going to take place for the oxymercuration and demercuration. So children, in this session, that is in session number 8, we have studied the 3 important processes of hydration. First one was acid catalyst hydration process. Second one was HBO, hydroboration, oxidation, and then third one is oxymercuration and demercurations. So these 3 are very important topic from examination point of view, which are basically coming under hydration, but in your syllabus they have been given in a separate manner: hydration, oxymercuration, demercuration and HBO. They had been given in the bifurcating manner. So it's no worries, but the topic will be in a similar manner. Okay, so this session number 8 we have been carried out with this 3 important topic which is coming under the same one, which is in hydration. Then the remaining 1 topic will be left, that will be going to get continued in the next class, that is in session number 9, and then we'll wind up with the alkene. Then the next third we need to start with the alkyne. So in this aliphatic hydrocarbon, 3 important component. First one is alkane, alkene and alkyne. So alkane we have been already winded up. Alkene, within 1 more session it will going to get winded up, and the third one alkyne we need to start with that. So this is how this aliphatic hydrocarbon chapter is going to take place. So until that time, we'll continue this next session with the next topics. So until that time, thank you class for watching this class. Thank you so much.